Limits of absolute values. We know that if y is equal to the absolute value of x, then y, which is absolute value of x, will be equals to x if x is greater than or equals to 0. Also, y will be equals minus x if x is less than 0. Examples. Find the following limits. We have 3 examples here. 1. Limit as x approaches infinity. Absolute value of 5 minus 3x over x plus 7. 2. Limit as x approaches minus infinity. 7x plus 2 all over 3 plus the absolute value of 7x plus 2. 3. Limit as x approaches infinity. Absolute value of x plus 3 all over absolute value of x. We'll go ahead to solve these 3 problems. If f of x is equals absolute value of 5 minus 3x, then we have absolute value of 5 minus 3x equals 5 minus 3x. If 5 minus 3x is greater than or equals 0, and this implies that 5 is greater than or equals 3x, which implies that 5 all over 3 is greater than or equals x, and this implies that x is less than or equals to 5 over 3. And absolute value of 5 minus 3x is minus 5 minus 3x if 5 minus 3x is less than 0. And this implies that 5 is less than 3x, which implies that 5 all over 3 is less than x. And this implies that x is greater than 5 over 3. So the limit as x approaches infinity, absolute value of 5 minus 3x all over x plus 7, we substitute minus the bracket of 5 minus 3x into our equation because x approaches infinity, meaning x is greater than 5 over 3. So we now have equals limit as x approaches infinity minus 5 minus 3x all over x plus 7 equals limit as x approaches infinity. Here, the highest power in the denominator is x. So we divide each and every term by x. We have minus 5 over x minus 3x will be plus 3x over x over x over x plus 7 over x equals minus 5 over infinity. We substitute infinity for x plus 3x divided by x is 3 all over x divided by x is 1 plus 7 over infinity equals minus 5 divided by infinity is 0 plus 3 all over 1 plus 7 divided infinity is 0. This gives us 3 all over 1, which is simply 3. That's our solution. We move to question number 2. Find the limits as x approaches minus infinity of 7x plus 2 all over 3 plus the absolute value of 7x plus 2. If f of x is equals to absolute value of 7x plus 2, we have absolute value of 7x plus 2 will be equals to minus 7x plus 2 if 7x plus 2 is less than 0. So this implies that 7x is less than minus 2. It implies that x is less than minus 2 over 7. So our equation becomes equals limit as x approaches negative infinity 7x plus 2 all over 3 minus 7x plus 2 equals limit as x approaches negative infinity 7x plus 2 all over 3 minus 7x minus 2 equals limit as x approaches negative infinity 7x plus 2 all over 3 minus 2 is 1 minus 7x. The highest power here in the denominator is x to the power of 1. So we divide each and every term by x. We have equals limit as x approaches negative infinity 7x over x plus 2 over x all over 1 over x minus 7x over x. Have 7x divided by x will give us 7 plus 2 over negative infinity. We substitute in negative infinity all over 1 over negative infinity minus 7x divided by x is 7. This gives us 7 plus 2 divided negative infinity is 0 over 1 divided negative is 0 minus 7. This equals 7 over negative 7 equals minus 1. That is our solution. We move to the last question of the day. Question number 3. We have limits as x approaches infinity. Absolute value of x plus 3 over absolute value of x. Since absolute value of x is greater than or equals 0, this implies that absolute value of x is equals x. So we substitute that into our equation. Limit as x approaches infinity x plus 3 all over x. The highest power in the denominator here is x equals limit as x approaches infinity x over x. We are dividing each term by x since the highest power in the denominator is x over 3 over x all over x over x. This will give us x divided by x is 1 plus 3 over infinity all over x divided by x is 1. And we know 3 over infinity is 0, so we simply have equals 1 plus 0 all over 1. We have 1 all over 1, which gives us the answer of 1. That will be it for today. See you in the next video. Don't forget to like, share, and subscribe.